Good afternoon, everyone. For those, I think everyone in this room, or just about everyone in the room knows, but for those of you online, I'm Marcus Yeover, Chief Executive of JNCC. Just going to say a few words to introduce the talks you'll be hearing after I've finished. So first, just a few words about air pollution work in JNCC. It does have a long history. We've been doing work on air pollution pretty much since JNCC was set up, but it has been a sort of chronically under-resourced area of work, and for many years it was really just you, Claire. You were the only person working on air pollution in JNCC and valiantly taking that forward. I'm very pleased to say that we do now have a bit more money that we're able to put into the work, so we do have a slightly more resilient team, and that's really good to see. Because in the end, air pollution is something that does have a really profound impact on various aspects of biodiversity, both in the UK and internationally, although it's something that is rather hidden from most people's view. So some of you will know that my background is as a botanist. I have a particular interest in bryophytes and lichens, and many of the epiphytic species of bryophyte and lichen, those that grow on trees, have shown remarkable changes in distribution over the years in relation to air pollution. So over maybe 100, 150 years, many of these epiphytes really declined right across the UK because of high levels of sulfur dioxide pollution. Over the past 20 or 30 years, they've shown a remarkable expansion back into areas that were previously polluted, right into the heart of some of the big cities in England and Scotland, because sulfur dioxide pollution has declined. And the big worry now for those species and for other aspects of biodiversity is nitrogen, which you will be hearing a bit more about in a minute. So this Nitrogen in the Air initiative is going to be a series of talks throughout the month of March. I think there's 6 in total, and it is aimed at just promoting the work that we are doing within JNCC, particularly on nitrogen pollution, but a bit on air pollution more generally. And it's part of the Nitrogen Futures project, which is a collaborative UK-wide project coordinated by us in JNCC. So I think that's quite enough for me by way of introduction. So without further ado, I will hand over to Claire Whitfield.
Okay, thank you, Marcus. So as Marcus says, I was JNCC's air pollution specialist for many years. I'm one of the secondments to work on EU transition at the moment. So I've handed over the reins to others at the moment, principally Susan Sapala, but she's not here to give the talk today, so I've stepped into her shoes. So I'm going to give a bit of background to air quality and the natural environment, providing a bit of history about how the issue became so widespread, and how JNCC and its predecessor bodies became involved and concerned about air pollution. And really the idea is this sets the context for the much more detailed and nitrogen-focused talks that are to come over the next few weeks. So I think it's useful to start off with thinking about the pathways for exposure. So when we consider air pollution, we need to be mindful there are lots of different types of air pollutants emitted from lots of different types of emission sources. When pollutants are emitted, they disperse and dilute in the atmosphere, and depending on how much pollution was emitted in the first place and the dispersion, it leads to elevated concentrations in the vicinity of the source. But those pollutants are also transported long distances, and they're often transformed through chemical reaction in the atmosphere, sometimes producing secondary particles and aerosols, or secondary pollutants such as ozone. And they can be transported very long distances from the source, and that too is an exposure route for both humans and ecosystems. And the third exposure route is through the, well, for ecosystems, is through the wet deposition of pollutants, through washout those particles and aerosols through precipitation. And this is particularly important in upland areas where there's plenty of deposition. So in the series of talks, we're focusing very much on nitrogen deposition, but I'm going to give a bit of history about some of the other air pollutants in this talk. We're also focusing on the natural environment, but air pollution is a very significant issue for human health as well. And it seems that over the last few years, there haven't been many weeks gone past when air pollution hasn't made it into the headlines. It's become extremely high profile in recent years, and that's partly because of some very high profile court cases against the UK government led by Client Earth, challenging the government's failure to meet standards for nitrogen dioxide in some of our urban areas. There's also a plethora of new science showing just how damaging these pollutants are. They've a much kind of wider range of impacts than previously were understood. But of course, air pollution is nothing new. It's been around ever since we started burning things. And it's been a serious issue since the start of the Industrial Revolution, and when our increasing need for energy has relied on the burning of fossil fuels. And I want to take us back to the 1950s, and in fact the decades before that, where frequently in our cities, the populations were subject to urban smog events. And people exposed to really very high concentrations of black smoke and sulfur dioxide pollution. Principally, this was caused by coal burning, both domestic and industrial, and it caused thousands of premature deaths. The Great Smog of London in 1952 was one infamous example of that, where over 5 days of a smog event in the winter, there were over 4,000 deaths, and probably many more after that as well. And that event in particular finally kind of created a massive public outcry and concern over the issue, and ultimately decisive government action to tackle air pollution in the form of the Clean Air Act, which came in 1956 and 68. So the first of those introduced the concept of smokeless areas in our city, smoke control areas, where burning of coal and other solid fuels was no longer allowed. And that had a tremendous impact on improving air quality where it was implemented. I'd say in some northern cities in particular, and other areas dominate, well, in coal mining areas, they didn't introduce these smokeless zones because of the local coal industry and stuff. So air quality didn't improve in those areas quite so quickly as in London, for example. The second Clean Air Act of 1968 required factories and power stations and industry to use very high chimney stacks with the idea that you dilute and disperse. And that worked really well in terms of local air quality. At the time, there was technical abatement, well, there were technical abatement measures to scrub out the pollution from the stacks, but they were thought to be too expensive, so they weren't used. So instead, dilute and disperse was the approach. That's all very good, except you realise it has to come down somewhere. And this led to long-range transport of air pollution and well-known issue, acid rain, acid deposition. First discovered really in Scandinavian lakes, particularly Norway in the 70s, slightly earlier perhaps, where they were seeing widespread acidification, big biological and chemical changes in their lakes and soils surrounding them. The fact that pollution caused damage to the natural environment wasn't new. As Marcus said, for tens of years, the effects on the natural environment are understood in terms of, for example, lichen distribution, etc. But what happened here is it was moved very much from a local issue to an international transboundary issue. And I like this image here from Acid News, which is a publication from a Swedish and Norwegian NGO on acid rain. And this sort of depicts a big cloud of pollution and a skull coming from the UK over to Norway, where we've got some dead fish and mountains. It shows how people were thinking about it at the time. So the immense scale of the issue and the damage it was causing provoked an international policy response, and it led to the formation of the Convention on Long-Range Transboundary Air Pollution in 1979. This was the first multilateral agreement that dealt with air pollution, and the aim was to prevent air pollution impacts, obviously, but particularly focusing on long-range transboundary impacts. And along with setting emission limits for countries, it also establishes mechanisms for information exchange, science exchange, and research, and for the monitoring of pollution. So in 1985, there was a protocol, the first sulfur protocol, aimed at reducing emissions of sulfur from contracting parties to the convention. They were obliged to reduce sulfur emissions by 30% to tackle this acid rain problem. The UK didn't sign up to that at the time, contributing to its reputation as the dirty man of Europe. The UK was very resistant to this, largely as a consequence of the CEGB, the Central Electricity Generating Board, public at the time, and the coal industry. They resisted very much the need for any change and didn't accept the science suggesting that emissions from power stations in the UK, for example, was damaging lakes in other countries. At the time, they funded a substantial research programme to look into this in more detail. They were very much accused of just kicking it into the long grass and buying time, but it did generate some science, ultimately. It's useful. There was a big kind of outcry in Europe about the UK's behaviour here, and I've been having good fun in trying to find some cartoons and things for this presentation, in reading some old newspaper articles and ambassador news about the reaction to the UK's resistance. It's quite entertaining reading. So over time, the science became very strong, really, the impacts unequivocal, and there became evidence of widespread impacts in the UK as well as Scandinavia. And at this point, the Nature Conservancy Council, a predecessor to JNCC, started to see damage in some of protected sites in Scotland, Wales, and the wider countryside too. So there's a couple of examples of some of the reports that published in the 80s. And around this time, there were substantial research programmes funded by government, research councils, and indeed the NCC had put a lot of money towards air pollution research at that time. There were also a number of monitoring programmes which were set up, including the Uplands Waters Monitoring Network, which still runs today, to try and understand those impacts better. And despite Britain's initial resistance to signing up to the first sulphur protocol and a target of 30%, we did actually meet that 30% reduction in our emissions. Arguably, because of the demise of much of our heavy industry and the privatisation of our electricity companies, that helped to contribute to, as we say, a more positive commitment to our reductions. But in the early 90s, the second sulphur protocol was being negotiated, and Britain did sign up to this. And the interesting thing about this protocol, which required really further quite substantial reductions in our sulphur emissions, interesting thing is the emission reductions were negotiated on the basis of an effects-based policy or an evidence-based policy, and this was new. Rather than setting arbitrary limits across all countries, they were targeted at looking at using a critical loads approach, where you map the sensitivities of soils and freshwaters across Europe, you overlay modeled deposition maps, and look at which areas are most vulnerable. And then you can, using source attribution modelling, look at where it is most effective to reduce reduce emissions in order to get the maximum benefit across the different vulnerable areas. And that was very much the basis of the second sulphur protocol and further protocols since that time. And JNCC at the time and the newly formed country nature conservation bodies did some work at this time to inform the government's position on the second sulphur protocol, which I understand was fairly influential. And we did a piece, well, not me, but previous staff did a piece of work looking at the relative benefits for triple SIs of different emission scenarios or different cost scenarios, to show the relative benefits to the protection of triple SIs. And that did inform government's position, as I said. So over this time, we were really getting on top of sulphur dioxide emissions, and I'll show a map shortly, a graph shortly of how they've decreased. But it was becoming very apparent that the story wasn't just about sulphur. There was a range of other pollutants, particularly nitrogen-based pollutants, which were really important, as well as ozone, which is a secondary pollutant formed by oxides of nitrogen and volatile organic compounds. So the Gothenburg Protocol in 1999 moved away from looking at single air pollutants to looking at multiple air pollutants, setting emission levels for a variety of pollutants. And the issue of nitrogen meant that we weren't seeing the recovery we might have expected, or full recovery we might have expected from reducing the sulphur dioxide pollution. So this graph, it's slightly difficult to see the different colours, there's too many lines on it really. But this shows from 1970, the emissions in 1970 normalised for each pollutant. Shows how they've decreased over to 2018. So if we look at the yellow line, you can see an massive reduction in sulphur dioxide concentrations, well over 95% from the levels in 1970. And as I say, we've had some recovery from that, but not as much as expected, because while sulphur was decreasing, we see the blue line, nitrogen dioxide, for next 20 years didn't really have much of a change, nothing particularly significant. So we were concentrating on sulphur, ignoring the nitrogen. The other line I'd like to draw your attention to is the green line, which is ammonia, and that we only have data from 1980 on, but that's pretty flat in the first, the year 2000, and then some levelling off, but not a great deal, and a worrying upward trend at the end. So it is a good news story in terms of this emissions map, and I think we must remember that. When we talked before about air pollution being in the headlines a lot, things have improved greatly, but the nature of pollution is changing, and our understanding of how the human health impacts and the ecosystem impacts has increased. It's still a very serious issue. So reactive nitrogen, the subject of this series of talks. So when we talk about reactive nitrogen, it's to differentiate it from nitrogen gas, an inert gas that makes up 78% of our atmosphere. Reactive nitrogen are forms that are available to plant uptake, for example, so compounds of nitrogen. And we're really interested in two types of nitrogen when we're thinking about ecosystem impacts, and they are oxides of nitrogen, which principally come from transport and combustion sources, and ammonia, which is a reduced form of nitrogen, which in the main comes from agriculture, key livestock production, livestock manures. Both those pollutants are toxic at high concentrations or quite low concentrations in the case of ammonia, which can cause direct damage to ecosystems. They also contribute to nitrogen deposition, to dry deposition and wet deposition. And that deposition causes soil acidification, so slowing down any recovery you might have seen from the sulfur reductions. And it causes eutrophication effects, or nutrient-nitrogen enrichment, which can lead to a variety of effects and competition changes in ecosystems, and we're going to have talks about that later in the series with a bit more information on that. Oxides of nitrogen are also a precursor to ozone formation, which is a serious ground level pollutant toxic to plants and humans, and responsible for a reduction in our crop yields, for example, in the UK, and massively so across the world. And they contribute to the production of fine particles, which are secondary fine particles, which are a significant human health issue. So you'll hear much more about nitrogen over the next few talks. I just want to touch on what JNCC's role is in terms of air pollution impacts on the natural environment. And I talked earlier a little bit about how NCC had become involved in the 1980s. Massive interest in acid rain came about. So I think the first thing to say about JNCC's role, and this is true of all of JNCC's work, I suspect, that our air pollution work has very much been a collaborative exercise across the country nature conservation bodies, JNCC, but also with governments in the UK and research institutes and universities, particularly CEH, we've worked a lot with. And I think the kind of niche that JNCC brings, and the country nature conservation bodies, is to help forge those links between our biodiversity commitments and policy and those of air quality. It's often quite siloed and often done in isolation, but I think we've helped bring together those two policy areas to show the relative importance for each other. We've also done some work on international collaboration. This talk will have demonstrated this is not a UK problem only, it's very much a shared issue across Europe and globally. So I guess initially our work focused very much on understanding the impacts. So that was bringing together evidence from local site level evidence through to broad scale evidence, using some of the UK surveillance schemes that JNCC is involved in for plants, etc. We've also done a lot of risk assessment work using critical loads and related metrics that we've developed for that. We've looked at methods for those risk assessments as well, and provided a range of tools and data for use in risk assessments, such as casework, which the country conservation bodies are involved in. So I've got a figure down at the bottom here of APIS, which is our Air Pollution Information System. That's a website that we fund together with the pollution regulators, the environment agencies across the UK, and the country nature conservation bodies, as well as CEH, that brings together lots of information on air pollution impacts and lots of the data that you might need on deposition, critical loads, etc. We've also funded our own research and helped inform others in their research priorities as well, trying to ensure that the natural environment, research questions around natural environment and air pollution get answered. There's lots more to be done in terms of those research questions, but I think our focus has shifted slightly now because there is really good evidence of the impacts. And our focus is shifting a bit to look at the solutions and measures that can be taken to address those impacts. And you'll hear much more about that from Alexander and Wewell. Okay, so the final slide just really sort of sets the scene for what the legislation and policy is at the moment. And so we have at the top there international drivers, and that's the LERTAP Convention, as I mentioned before, setting emission ceilings for a range of pollutants in the UK and across other contracting parties, but also providing that place for collaboration on the science, monitoring and strategy development for transboundary air pollution. At the UK level, we have a whole range of domestic legislation and what will be retained EU legislation driving action at the UK level and at, in the countries of the UK. So that focuses on meeting emission ceilings, for, emission limits for the countries. It focuses on emission limits from different industrial processes, from vehicles, It focuses on meeting standards of air quality with our individual exposure. Those, I'm going to just skip down to the bottom one before going back to our UK interval commitments. That sort of statutory focus is then delivered at local level through industrial regulation, through planning control, and through assessments, or informed by assessments under the habitats regulations, EIA, etc. And I skipped over that middle bit a bit. I just wanted to focus a bit more on what's happening domestically in terms of strategies for air pollution. So in 2001, there was a substantial UK air quality strategy looking at how the UK needed to meet its air quality standards, some of which were driven by Europe, others domestic. And that strategy almost entirely focused on human health and had very little commitments or requirements in respect to protecting ecosystems, as did the UK air quality strategy of 2007. In the last few years, the UK and world governments have all published clean air strategies, replacing those earlier ones. In the case of Northern Ireland, it's in preparation. And all those strategies have a much broader focus, including a focus on ecosystem protection and a big focus on addressing ammonia as a principal driver of nitrogen deposition and ecosystem change from nitrogen deposition. So it's a real shift over the time I've been working on air quality, and a real success really that the strategies are embracing the need not just to think about human health, obviously really important, but also to think about ecosystem protection and perhaps the co-benefits of emission control for both those. The other thing to point out is climate change policy. There are lots of benefits for air pollution, some trade-offs that we need to be aware of as well. But on the whole, very positive. The actions taken that will be taken for net zero carbon mostly will be very beneficial for air quality. And the final thing I want to draw your attention to before I hand over to Alexandra is future land management. So now we've exited the EU, all the countries of the UK are looking at what replaces the common agricultural policy. And because ammonia is such an important pollutant, and because it's principally from agriculture, it offers a real opportunity for using those future land management schemes to address this really important pollutant. And that's where the Nitrogen Futures project comes in. So I'll close my talk there.
Good afternoon to everyone, and thank you for Marcus and Claire for the previous talks and the introduction to the series of webinars. And thank you all for joining. And in my talk today, I'm going to speak about the Nitrogen Futures, a project that is funded by DEFRA and is coordinated by JNCC, a project that involved the UK government, involved administrations, and the country nature conservation bodies. The project, the scientific part, is undertaken by a consortium led by the UK Centre for Ecology and Hydrology, which is bringing together leading expertise from CEH itself, but also from Rothamsted Research, Heather Air Quality Consultants, Lancaster University, and Manchester Metropolitan University. So the photo shows some of the impacts of excess nitrogen in habitats. Some of you might have seen this green slime growing on trees, but might not have recognized it as one of the impacts of excess nitrogen in the air. So when nitrogen is present in the air in high concentrations, algae can colonize the tree trunks, leading to tree disease and eventually loss of habitat. In this photo, you can see a healthy moss on the left hand and a dead or impacted moss on the right side. Most species are very sensitive to excess nitrogen. And when exposed to concentrations above the critical loads, they suffer large die-offs. Sphagnum mosses are key species which grow in bogs, and they build one of the most characteristic landscapes in the UK, which are peatlands. And one of the important functions of bogs and peatlands is to retain water and help control floods. And so I've picked this quote from Chris Dean from Moors for the Future, which really illustrates the importance of preserving and restoring peatlands. So he says, there is no difference in my mind between getting sphagnum moss back on the top of the hill and building hard defenses alongside the river. So there's a lot of food for thought here, and it's very contemporary. As Claire mentioned, 78% of the Earth's atmosphere is made up of nitrogen, but most of it is an inert gas. Plants use the reactive nitrogen, which are actually scarce and limit plant growth. The problem, as Claire mentioned, lies when nitrogen is emitted by human activities and is then deposited in the soil and over sensitive ecosystems. So to complement Claire's diagram before, you can see that the biggest emitters of ammonia, it's agriculture, either by animal rearing, manure management, but then ammonia travels in the atmosphere and reacts with other pollutants that are produced by other human activities, such as energy production, shipping, flying, our cars, and all these combined will eventually deposit it in very sensitive habitats and cause habitat damage. So this graph shows how species richness in many natural habitats decline with increasing nitrogen deposition. Some of these habitats are very high valued and are key components of the protected sites in the UK. They host an independent community of plants, insects, fungi, birds, animals, and ourselves. We depend on these habitats. So what is the UK and the international community doing to overcome this problem? I think Claire already explained, but in my mind, I have these main drivers, which is driving the project as well. It's the 25-year environment plan, the UK countries' clean air strategies, the England strategy, it's already published, but the other UK countries are still working on theirs, and they are at different stages. And there's the Convention on Long-Range Transboundary Air Pollution that the UK is a member of, and then the national emission ceilings regulations that sets emission levels for several pollutants, and also obliged UK to have a national air pollution control program, which set objective measures. And these are the measures that we are going to base a lot of the product on this project. So anyways, meanwhile, and despite all this legislation, we still see high levels of nitrogen in UK, in the spread in UK habitats. It is fair to say, as Claire mentioned as well, that these levels have been decreasing for a while, mainly for nitrogen oxides and less for ammonia. But it's still quite a bit high, and we would like to see these go down. When we looking at our nature conservation sites, we have, as a general number, 60% of the UK nature conservation sites have excess levels of nitrogen. You can find this information on the Trends report published last year. It's quite very interesting if you want to look at it. So the main objective of the project is to produce information to support further policy development to decrease air pollution around designated sites. So it's a project that will focus mainly on around designated sites. So the project specific aims is to quantify the benefits from a range of potential emission mitigation options for ammonia and nitrogen oxides, to develop scenarios to maximize benefits to ecosystems near sensitive habitats and designated sites, and inform policy development at UK country and local scale. So the project has started last summer in August, and it will end in April, in a month's time. We have 6 work packages. The first 2 ones are already delivered. They form the base of the development of the models. Work package 3 and work package 4 are in progress at the moment. And we'll have work package 5 is the final report, which will be published in our website. And then we have work package 6, which this series of talks are a part of it. And we have probably the most important part of this project, which will be the stakeholders workshops that will start in summer 2020. So by the time we will have the information about the measures and what we can do about decreasing the nitrogen deposition around the designated sites, and we will discuss this with the stakeholders. In this slide, you can see how the work package are structured. So work package 1 and work package 2 were gathering data and developing methods to feed in the models, which is work package 3, which are modeling the information. And then work package 4 will test these models at local scale. And I just want to highlight how important the steering group discussions and decisions have been. So the steering group is composed by members of the UK government, the devolved administrations, the nature conservation bodies, and the scientists. And we've been meeting every year, and we exchange a lot of emails, I have to say, through the month. And it's been really a very intense brainstorming and work, and everyone is working together, which has been really pleasant. Yeah, and in the end, hopefully we'll have a final report that everyone could read, and we are producing very nice communication packages, which I'm sure that you will find, you will be able to see some of those around. So speaking a little bit about the work package 1, I debated where to add here the table with all the scenarios, but they are the names are so complicated that I gave up. And Susan suggested me to say, why don't you use these words mapping? I've never heard about it, and so I spent like 3 hours playing with it and just putting together all the words that are actually part of these scenarios, which, you know, they will analyze emissions, they will analyze agricultural measures, they will analyze things at country level, they will analyze cleaner zones, optimize scenarios, business as usual. So it's very complex. So, but anyways, the simple part of these, or at least the part I've understood from these scenarios, were that they are looking at several measures, and these measures include things like introducing low emission buffer zones around protected areas, which they are looking at, is it more useful to, for example, plant trees around the emission zones, or is it more useful to plant trees around the designated sites? So they are exploring this kind of measures. As I said, they are testing creation of tree belts around the sites or around the emission sources. They are also looking at agriculture measures. One of the measures is, for example, low emission slurry application, but there are several measures. The research is being really evolving in this area, and so this is very good news. And the other measure that these scenarios are exploring are the implementation of clean air zones. So after they have all these scenarios, some were built at national levels, others at local levels, they will test these scenarios at very local areas. These are our case studies. We have about maybe 12 to 13 case studies now. And so basically what the project will zoom into these local areas and see what are the impacts. Are the impacts better if you implement these measures at the local scale, or at the landscape scale, or at a national scale? And the result, it will inform the UK policy moving forward. So just going to show you how the results will look like. The results will look like a lot of maps and a lot of graphics, and hopefully some text with recommendations. But at the moment, I don't have a lot of results that I can show. They are still, improving the models and having a lot of discussions on how to show the information. But in this slide, for example, you can see how the ammonia concentrations would look like in 2030 if we keep business as usual, so the normal measures that are set at the moment. But if we implement more measures that were set by the NAPCP, and more measures that the devolved administrations also want to implement, you can see that that's going to be quite a big. So the ammonia concentration, it's higher where it's pink and red. The map showing the change if you implement these measures. So the output of the project will be a series of these maps showing what will be the result depending on the measures you're going to apply. The project will only not looking at UK at the wide scale. It will look at country level as well on local scale. And in this graph, you can see how the first results show. The first column shows the emission scenarios in 2017. By 2030, if we keep business as usual, we're not going to see any change. But if we start implementing the measures set by the NAPCP, we will see a big decrease. It also looked at other variations like high emissions or including cattle, but at the national level, you don't see a lot of difference. But when you look at the local scale, the difference are enormous. So watch this space. This is just the results at the UK level. We have to look at the local level to see really the big changes. So the preliminary results so far indicate that the UK-wide measures with additional spatial target measures optimizes mitigation where most needed for the benefit of sensitive vegetation. Basically, it says that you can apply the measures at the national level, but it's really important. It will be more benefit if you apply actually at local scales. And so this is probably where we will go and end up with. But of course, this, we will need a lot of discussion about these results and how to implement and how to bring people and discuss what we can do about the local measures. So work package 6 is the communication work package. Most of you know that we already have a web page, we have a logo, we already released some articles, we are on Facebook, Twitter, we organized this March Nitrogen is in the Air, which these talks are part of. We're gonna be present at CAPER, which is a big conference about air pollution that will take place in Swansea in the last week of March. And we're gonna try to make a live broadcast from there. I never did one, so let's see how it goes. We just published an article on JNCC Nature News, and we are producing some postcards, banners, pull-up banners to take with us to the stakeholders workshops. And we have an address, and just to announced that we starting the stakeholders workshops in the summer 2020, and so we already have an emailing list, and we have been in contact with our stakeholders. So thank you.